This room, I will show you the newest TEM machine. This one can reach to the resolution to 0.6 astron. So it's really good. This one is a very expensive one, and it's the first one they sold in the world, and we bought it. Okay. Yeah, we have a 0.8, another one, Titan, image 0.8 astron. This one 0.6 astron. So it has 2.2 improvement. The price is really high. The price improvement is much higher than the resolution. Yes, you have to pay a lot. And this room is specially designed, is fully isolated and also anti-vibration. So the bottom of this, it has a battery anti-vibration underneath. And all this room is isolated. You can imagine so sensitive equipment, it's so easy to get interference on the environment. So that's why this room is so special, and the old Wi-Fi signal has been blocked in this room. Okay. Let's go this room.
ايه لا سجلت يتكلم عن ال
This one is the Titan.
Oh, this is so you have more than one.
No. This one is the older generation. That one is newest generation. This one is 0.8 astron resolution. Yes.
But this is still a fully functioning TEM.
Definitely. Yeah. This still is a very nice TEM. It's also pretty expensive. Okay. But you know, nowadays higher impact journal, you must have some really fancy data. Otherwise, they will not accept, right? So that means higher impact generation is more expensive to publish there. So this one, like a few years ago, 2 years ago, there was a paper published in Nature. They used TEM to image the water structure. Okay, so this is really challenging. Without TEM, this is not possible. Okay.
So this is another TEM?
Another TEM. That one is the newest model. This one is older previous generation.
Can you tell us how expensive is it, or the range of?
At least a couple $1 million. So it's when you count it, you're talking about a million. Okay, this one is a more special one. This one is Titan Cryos. The name cryos means it's frozen because some sample, like a cell, you have cells, you can use normal TEM to observe structure, no problem. However, those cells are live creature, so they can secrete some protein or something surrounding the cells. So if you want to study the interaction between the protein and the cells, you need to know what type of the material surrounding the cell. However, for the normal TEM, you need to dry sample, and then you cut the sample. Once you dry the sample, you already remove all the material surrounding the cells. How can we see the environment? This is the method. You freeze the cells. You freeze the cell and surrounding media. So you basically freeze the information just like a snapshot of the cell. Okay. You have all the information surrounding the cell. Then you cut into thin slices and then observe in the frozen state here. So by this way, this can observe the frozen, all the information surrounding the sample. Okay. So this one has a wide application in the biological study. In our university, we have a membrane center where the people can fabricate a membrane and use this membrane to test its antivirus ability. So that means there's some bio stuff growing on the surface of the membrane. If you dry the membrane, you lose those bio stuff. So this is also the way they study the biofilm. They cut the film, freeze it, and image it. Then you will know what's the effect, how effective is the biofilm. So this one, when we bought this, there were only 12 cryos in the world. This is one of them.
12?
12, yes. And this one is pretty old because it's installed here since the beginning of the university. It's 2009. So it's almost 10 years, but still pretty advanced. Nowadays, more and more bio paper published in Nature and Science is using the cryos. Yeah, so now this area becomes really, really hot area. Many people want to study their sample using cryos.
So where to put the sample?
See that small window?
Yeah.
That's the place. Because it's enclosed. Because you have to image them in the frozen state. So it's enclosed.
How thin are the slices?
Okay. The thin slice normally is in less than 5 micron. So even in 1 micron or 2 micron, even in nanometer range. So it's really challenging to cut the sample into that thin slice. So typically when you do TEM experiment, sample preparation will take you a few days or even 1 week or 2 weeks to prepare a sample. And then you take the sample here to do the image. The image may take 8 hours or 12 hours for the image. So the whole process for TEM is really time consuming. It's not an easy job. It's not something you can just have fancy tool, put your sample there, you get really nice data. It's not that easy. It's a really long time. You can think about one run takes a few days or even 1 week. And if that sample is not perfect, you cannot see your sample. Yeah, cannot see your feature. You have to go back to the whole process and to do that again. And that's also part of the reason why the high impact journal Nature of Science has the papers here, because it's really difficult, really challenging. It's high tech work. Okay.
How much the accelerating voltage for the electrons?
This one, I'm not sure. We don't have the stuff here. Well, if we meet the stuff, we can ask him this question. For the technical part, we have.
This one is under maintenance now, or it's ready to?
It's actually those things. We have 2 dedicated engineers, stay in KAUST, full time. Just keep maintaining these things. This is really sensitive and high maintenance equipment. So these one always we have staff to check the status and give the maintenance. So these things we need the engineer to be standby all the time.
And what's the number 2 for?
Oh, TEM2. That's just the number of TEM. The room number. We have each individual room. We have 1 TEM.
I see when it increases, it's newer ones. So I thought
No. There's no such sequence. They just maybe just like a hotel. You have this room available, put it in. Another room available, put that in. There's no that sequence for the generation.
These are all specially built rooms, or
Exactly.
What
has to be.
what kind of isolation are you using? Or?
They have the metal inside.
Okay.
Isolate. That's the metal net to isolate hold this room.
And you initiated the isolation from the beginning? Or?
No. I joined the KAUST at 2011, so I'm not the founding members. But we have founding members in TEM group. Yes, when they start this, they wear the helmet, and they build from the beginning. So it's really really challenging in the beginning. Nowadays, it's a more routine. It's more standard. Has been standardized.
Do you have more TMs than 3, or
No, we have this totally 1, 2. It's a 6. We have 6 TMs. Yeah. In each room, we have 1 TM, and in all this side is a TEM preparation. Yeah. So to do TEM is fancy, but it's really time consuming and really labor intensive. Okay? Yeah.
How much does they cost?
Oh, I have no idea what the exact number, but at least $2 million.
The old one?
Huh?
The old one?
Yeah, even the old one. Yeah, even the old one. You know, at that time we bought it, it's new one, so it's not cheap. Okay. Yeah. Okay. Then let's go to the AFM. So this is another important region we characterize the sample. You know, this one we characterize the surface property of the sample. So you want, for example, this surface, you want to know the quantitatively what's the roughness of the sample, and also you not only want to know the topography, you also want to know whether this one is just really hard or very soft, and also whether it is adhesive. And if it is adhesive, what's the adhesion force? So all these things you want to measure, and this is the tools. So basically, they use a very tiny probe to touch the surface, and then scan the surface. So when the surface is up and the needle is up, when it's down, it's down. So then when it's scanned, it gives you very detailed surface, but it will scan one line by one line. It's pretty slow, but eventually after you scan the whole surface, it tells you the surface roughness. And also because we have a probe, so you can touch the surface by reflection force, you will know what's the adhesion force, and also elasticity of the surface. And it use a probe and then use a laser to shooting on the arm of the needle, and then see if the tip is have the change of the position, then the laser changed. So by collecting the reflection of the laser, it knows the movement of the tip. So that's the principle of the AFM. It's also a very important tool to study the material surface property. Okay.
So when do you use TEM and when to use it?
TEM is used to analyze the cross-section. So if you have sample, you want to see the cross-section internal structures and features, what's the size, you need to use TEM. But if you just want to see the whole surface, then you use AFM.
What is the resolution of AFM?
AFM is down to picometer. It's really, really precise. Any more questions?
So the image are not cross-sectional, but the
surface. Surface, give you surface. Like in your, okay, I think the time is done. Okay, let's go then.